Okay, let's do some integration. All right, starting with f of x equals 3x squared minus 5 over the cubed root of x. Okay, so let's write that out. And I'm going to write the cube root of x as x to the 1/3 because we're going to do the power rule. And what we're going to do is write the integrand as a sum of powers by dividing by x to the 1/3. And we can do that because the denominator is only one term. So since it's only one term, we can divide term by term, like this and like this. All right, so let's do the two divisions. First, we're going to divide x squared by x to the 1/3. All right, that's x to the 6/3 divided by x to the 1/3. Subtract those exponents, and we have x to the 5/3. And then we have 5 divided by x to the 1/3. That's 5 times x to the minus 1/3. And now we're ready to do the power rule. The power rule for integration, we add 1 to the exponent and divide by the new exponent. So we're going to add 1 to 5/3. That's 5/3 plus 3/3. Okay, so we have 3 x to the 8/3. And then divide by 8/3, which is the same as multiplying by the reciprocal, multiplying by 3/8. All right, now apply the power rule to the second term. Add 1 to the exponent, add 3/3 to minus 1/3, so we have 5x to the 2/3. And then we divide by 2/3 or multiply by 3/2. Okay, and that's it. That's a straightforward power rule. Okay, let's look at our next example. Here we have the integral of the square root of 2x plus 3. So we have an inner function. Our inner function is 2x plus 3. It's inside the square root. That's why I call it an inner function. And it's a linear function in x. That is, x only appears to the exponent of 1. So that's the second type of u substitution. We look for that situation where we have an inner function where x is a linear function in x, and we put u equal to that inner function, 2x plus 3. Okay, so in this case, du is equal to 2dx. Now here we're going to substitute for dx. So when we substitute for dx, we'll put dx equal to, divide both sides by 2, dx equal to 1/2 du. Okay. Now, often when we do this type of substitution, we solve for x as well. We take this little equation and solve for x as well. We do that if we have some expression in x outside the composite function, like out here. But since we don't have that, we're not in that situation, we have no expression in x to replace with u, we don't have to do that in this case. All right, so what we're going to do is just use what we have and do a substitution. So for dx, we're putting 1/2 du. We'll do that direct substitution, put the 1/2 outside the integral, and we'll put the du here at the end as usual. And here we're just going to substitute for square root 2x plus 3, that's square root u. This expressed as a power is u to the 1/2. So we're ready to do the power rule right away. That's 1/2 u to the 1/2 plus 2/2, that's u to the 3/2, divided by 3/2 or multiplied by 2/3 plus c. So we're essentially done now. All we have to do is put back x. So instead of u, we'll write 2x plus 3. Okay, and that's it. That's the antiderivative. Let's look at the next example. Okay, so here we're going to, let's integrate x divided by 5x squared minus 3 to the fourth. So now we're in the situation where we have an inner function. Here's our inner function. Notice the inner function is not a linear function in x. Here we have an x squared. This is the first type of u substitution, where the derivative of the inner function is sitting on the outside, except for perhaps a constant. So the derivative of 5x squared minus 3 is 10x, and here we're just missing the 10, but we have the x. So that's the first type of u substitution. So we substitute u equal to the inner function, 5x squared minus 3. And du is equal to 10x dx. So this x dx is going to become 1 over 10 du. So that's basically how we get rid of this x. It's part of the du. Alright, now we're ready to substitute. So again, for x dx, we're putting 1/10 du. And we're left with 1 divided by, instead of 5x squared minus 3 to the fourth, we put u to the fourth. So now we have a straightforward power rule. It always boils down to a power rule. Okay, this is u to the minus 4. So written as that, we're ready to use the power rule, add 1 to that exponent, and we get u to the minus 3, and divide by minus 3. And that's it, we're done, except for putting x back. So let's do that right away. Instead of u, we'll put back 5x squared minus 3. And just copy it over exactly as is. And that's it. Okay, and we're done. Okay, let's look at D. Here we're integrating x minus 5 divided by the square root of x plus 1 dx. So this is our inner function. It's underneath the square root, and this inner function is a linear function in x. X only appears to the exponent 1. Alright, so this is the second type of u substitution. Now du is equal to dx, so we're not going to get rid of this x. This x is not going to be part of the du. We're going to have to substitute x equal to u plus 1. Just switch this around, subtract 1 from both sides. Sorry, u minus 1. Subtract 1 from both sides, and we have u minus 1 is equal to x. So here, for x, we're going to substitute u minus 1. This u minus 1 over here. Okay, so let's start with our substitution. Okay, so x is u minus 1. And then we have that minus 5 over there. Divide by the square root of x plus 1. X plus 1 is u. And du is equal to dx. So we'll put, for dx, we'll put du. Okay, so we're integrating u minus 6 over u to the 1/2. So this is a familiar situation where we have a power of u, or a power in the denominator, and we can divide the numerator because this is a single term. So we can do the division. Okay, so let's do that. So u to the 1 divided by u to the 1/2. That's 1 minus 1/2 is equal to 1/2. So we have u to the 1/2 minus 6 u to the minus 1/2. Okay, and we're going to integrate that. Okay, now let's actually do the power rule, do the integration. Add 1 to the exponent, so that's u to the 1/2 plus 2/2, that's u to the 3/2. Divide by 3/2, or multiplication by 2/3. Then we have u to the minus 1/2 plus 1, that's u to the 1/2. Divide by 1/2, or multiplication by 2, plus your constant. And just finish this off by substituting. Instead of u, we put back the x plus 1. Okay, so let's do that. So we have x plus 1 to the 3/2 times 2/3 minus 6 x plus 1 to the 1/2 times 2 plus c.